Hi, my name is Mohamad. Me and my colleagues David and Ashkan investigated Stack Overflow's questions to predict and characterize questions without accepted answers. It's my pleasure to present to you our paper. Well, developers use Stack Overflow to solve their coding problems as askers or visitors. Visitors are interested in accepted answers because they can confidently reuse them. But the problem is that the number of unresolved questions is increasing. We consider questions without accepted answers as unresolved questions. As you can see, only 24% of the questions haven't received accepted answers by January 2009, while this rate has increased to 47% by January 2019. In our work, we designed some novel features that affect attracting accepted answers and propose an online tool that predicts whether a question will get an accepted answer or not to help users. Also, we answered 4 research questions about predicting unresolved questions, identifying important features to get accepted answers, assessing the effectiveness of Stack Overflow's hints, and investigating the role of tags in getting accepted answers. Related studies have mostly focused on questions with any answers, not accepted answers. But several papers have worked on unresolved questions. Trudeau et al. Worked on about 400 questions and concluded the categories of questions could affect getting more accepted or unaccepted answers. Rahman and Roy worked on 8,000 questions with at least 10 answers. Their feature set included reputation and votes. Califat et al. Worked on 87,000 questions and extracted several categorical features to resolve a question. They worked on questions that had been submitted in a month. Also, Wang et al. Worked on 55,000 questions that had been asked in 2015 to predict the response time of an accepted answer. Different from these papers, we worked on 18 million questions. Moreover, we didn't use any features obtained after the time of posting questions, such as reputation. This led us to build an online tool to predict whether a question will get an accepted answer. Also, we designed several novel features. Well, we used some features from the related work and designed several novel features. These new features include scores and earned badges that reflect participants and experiences. Also, we extracted some content-related factors such as lines of code that show presentation quality. As you can see, we designed 4 novel tag-related features. Count represents the number of questions for each tag, and time index is an estimation of tag creation date. For instance, problem rate shows the number of asked questions with a specific tag concerning its creation date. Also, we know that a popular tag could be used at a higher rate than an unpopular one, so we divided popularity by the count to reach tag quality. Our design features resulted in considerable performance. The terrain classifier with XGBoost algorithm performed with an AUC of 71% that shows an adequate discrimination ability. By considering XGBoost feature importance as a measurement, we could have an insight into the relative importance of our features. Based on this comparison, tag-related and content-related factors got notable results. These features show presentation quality and the effects of tags. User-related features also resulted in high importance scores that show users' skills and experience. Before and while asking a question, users read tips to ask appropriate questions. Besides, the informed badge explicitly indicates who has read a tour page. Another badge is Scholar, which indicates its owner has got an accepted answer. Scholar was more important than informed in our results. Also, as you can see, the probability of getting an accepted answer is 52% for who has earned informed badge, while this probability is 59% for the scholar. So reading documents is not significantly effective in comparison with other features. In our results, tag-related features showed notable importance in attracting accepted answers. These features can reflect the role of experts, attraction, and the rate of posting questions in getting accepted answers. In another analysis, we find questions with general tags are more likely to get accepted answers in comparison with questions with technical tags. For example, a question with a string tag has high probability to be resolved. Now, how can we get more accepted answers? The importance of content-related features reveals writing clear, complete, and readable questions relates to the chance of receiving accepted answers. The importance of user-related features shows experienced users can get more accepted answers. Therefore, developers can gain experiences and skills in asking questions to get their desired answers. Besides, developers can increase their chances to get accepted answers by attracting more experts. In fact, they can increase their chances by choosing more relevant tags. A classifier can help users in another way. We developed an online tool to predict whether a question will get an accepted answer or not. Developers can enter their questions in this tool to find the probability of getting accepted answers and check the features of their questions so they can modify their questions and tags to ask better questions. Many thanks for your attention.
Hello, everyone. So I'm Chayong Rakit Rezakun. I'm the chair of this session. So let's start with the first paper from Mohamad. We have a few questions already. Yeah. So Mohamad is ready now. So Shrida asking, wondering if you can consider text, code, and screenshots as individual component in SO posts. Did you use different techniques for processing them or the same?
Actually, we didn't use any individual components to build our prediction model and use a collection of text-related, code-related features to train our model, but we didn't screenshots. So actually, we know that most of questions don't have any screenshot, and our AUC of our prediction model was 71%. I don't think that individual components such as only text-related features could have enough accuracy in our research.
Okay, thanks. The next one from Alexander. Would the tool discourage authors from asking questions?
No, the authors can modify their question to see what happened and see our prediction results. For example, they can see some features about presentation quality or number of tags. They can modify their question and see that, for example, adding another tag, by adding another tag, they can increase their chance to ask their question. They can have some feedback on their questions to ask better questions.
Okay.
I can share my screen. Here is, you can see the demo. Okay, here is our tool. For example, somebody can ask their question here and use a tag and see what happened. Also, they can choose their Erlang badge and then modify their question to ask better questions. Are you hearing me?